last section of chapter 1 is dealing with linear inequalities. We talked yesterday about linear equations and solving linear equations. Then the only really big difference today is now we're going to throw our inequality symbols in there. Less than, greater than, less than or equal to, greater than or equal to. But what I will tell you is that we're going to look at lots of different kinds of inequalities. So we're going to have single inequalities where we just have one inequality in a problem. And then towards the end, we'll get into compound inequalities that use like the and the or statements. And then we're going to graph it. And when we talk about graphing with linear inequalities, we are going to graph like we have in the past, but we're not going to use like open circle and closed circle anymore. We're going to use brackets and parentheses. We're going to use the interval notation to express our answer and to put it onto the number line. Okay, so a couple of things just to kind of remember. First of all, if I were to give you just a single one-step inequality. I picked out this one in particular because the one thing that we have to remember that when we do an inequality, in this case the first step would be to divide by -3, and that would make this a -2, but because I divided by a negative, then that makes my sign flip. Okay. And the reason we flip the sign is because I want this inequality to be true, right? And so what we're saying here, yesterday we got an answer of like x equals -2. That was the only thing that worked. Well, today we're saying anything bigger than -2 is going to work. If I don't flip my sign, it's not going to work. And so here I could pick out any number that's bigger than -2. So like I like to use 0. 0 is a piece of cake to plug in. If I plug in 0 for x, -3 times 0 is 0. 0 is less than 6. But if I had not flipped my sign, then I would be saying anything less than -2 would really work. And that's not really the case, okay? That would be numbers like -3, -4, and so on. But if I plugged -3 in here, -3 times -3 is 9. 9 is not less than 6, okay? So that's why we flip the sign, but we got to make sure we remember to flip the sign. And that's probably one of the things that we forget to do the most. And main reason is because we're going to look at some problems like we did yesterday where we're going to have like multi-steps going on in them. And so we have to continue to remind ourselves, if I ever multiply or divide by a negative at any point in time throughout the problem, that sign needs to be flipped. Okay? Addition and subtraction does not affect it. Only multiplication and division of a negative would affect it. All right, so let's look at kind of a multi-step inequality here. We're going to solve for x. Very, very similar to what we did yesterday. And then we'll talk about how we're going to express our answer. So we're going to add 2x. Since I moved the x's to the left, we're going to move our numbers to the right. So we get 5x is less than 11. And then we divide by 5. We get x is less than 11/5. So we're going to write our answer 3 ways. First way that we're going to write it is simply the inequality. X is less than 11/5. Sometimes they use brackets. I don't typically use brackets. But all this is saying is for any value of x, x is less than 11/5. That's all that terminology is saying. But I'm totally okay if you just leave it like this. You don't necessarily need to put it in the brackets. I just show that to you because you might see it written like that with the brackets, and so I just wanted you to see that. Okay, the second way we're going to write it is an interval notation. What I like to do, first of all, is graph it, which is our third. And I think then coming up with the interval notation is a little bit easier. So the order that you do this in doesn't really matter. I'm going to make a number line. Okay, 11/5, we just have to think about where that would be on a number line. If I take 11 divided by 5, it's just a little bit bigger than 2. So 11/5 would be like right here, because 10/5 is really 2. So 11/5 would be just a little bit bigger than 2. Okay, if we have a less than symbol, there's no equal to on it, then that's kind of like what we talked about earlier in the chapter. Less than or greater than is going to use a parenthesis. We're going to use parentheses for less than or greater than, and we're going to use brackets for less than or equal to or greater than or equal to. So that kind of tells us what symbol we're going to use. So in this case, it's going to be a parenthesis, and because my graph is less than, we're going to open it to the left, and so it would be a parenthesis that looks like that. And then we're going to shade it to the left. So we're saying all numbers less than 11/5 would make this work. Anything that falls in this little shaded area should be a solution. So here we're going to have a lot of numbers that work. I could plug in like 0 and 1 and things like that if I wanted to check it. As far as interval notation goes, we talked about this like when we did domain and range. How far left is this graph going to go on the number line? Forever, right? Because my arrow is going to continue on. It's never going to stop. So it's going to go to forever, which is infinity. We always go left to right as we move across. And we're going to keep moving across the number line until we get to 11/5. And we're not including 11/5 here, so we use parentheses. Okay. I like to do the graph first, and I think it makes this a little bit easier. You can do the interval notation first if you want to, but I always like doing the graph first. Okay, so that's just kind of the 3 ways that they're going to ask us to write our answer today. A little bit different format. Okay, let's look at another one. 13 minus 7x is greater than or equal to 10x minus 4. Okay, you got all kinds of options here, right? One option would be to move the x's to the right. Yesterday we talked about keeping the x's positive, and that's okay. But when we do inequalities, we always want to finish with the variable on the left. We don't really care about that when it's an equation. But when we do inequalities, we want to finish with the variable on the left. Okay, so you could move it here and then move it back, or what I'm going to do here is I'm just going to go ahead and move the x to the left right now. Okay, if you would rather add 10x, you're still going to end up with the same answer. And since we moved x's to the left, we'll move our numbers to the right. So we have negative 17x is greater than or equal to negative 17. And then we're going to divide by negative 17. And as we talked about at the very beginning, because I'm dividing by a negative here, this sign now needs to flip. And that's why you got to keep reminding yourself. If I ever multiply or divide by a negative, that sign's got to be flipped, and this would become a positive one. Hey, that would be my inequality. If I were to graph this, we're going to start at 1, and 1 is going to have a bracket on it, and it's less than, so it's going to be shaded to the left. So very similar to the one we did just a second ago, except it's a bracket instead of a parenthesis. And once again, it's moving to the left forever. And as I'm going to move to the left until I get to 1, and at 1, I'm going to put a bracket. So that's why I think graphing it, then I can just take what I put onto my number line and use it to write my interval notation. I think it makes it a lot simpler. Okay. Any questions on that? Okay. If I had added 7x here and added 4, I would have 17 is greater than or equal to 17x, and I would have x on the right. But I want to finish it so x is on the left, so I would still finish the same way. Okay, that's why it really doesn't matter what your first step is. You should always finish, when we do an inequality, you should always finish with the variable on the left-hand side. Another thing that we're going to see from time to time, and this is another reason or situation where inequalities will come into play, is it'll ask us to express our domain as an inequality. And so we're going to talk about some scenarios where we might have a domain that uses an inequality. If I give you a function, this time it's a square root, okay? Early in the chapter, we said when we talk about domain, we never want to have a denominator of 0. So that's one thing we always got to keep in the back of our mind. If I have a denominator, then I can't have a denominator of 0. If I have a square root, which we haven't seen a whole lot yet through chapter 1, but if I take a square root of something, what numbers, as of right now, can I not take the square root of? And yeah, you're on the right track, but just thinking about what number can I not put in under the radical right here? So what happens if I would take the square root of 0? You get 0. So that one would be okay. But we can't take the square root of a negative. Okay? Can't take the square yet. Eventually we'll get into imaginary numbers. You guys are excited about that, right? But right now, we don't have to worry about imaginaries, okay? We're going to act like we've never even heard of imaginary numbers before, right? But I can't take the square root of a negative. So if I ever have a square root of a negative, then for right now, we can't do that, okay? Square root of a negative is always going to equal no solution for right now until we get into the imaginary set. So what we're going to look at here is what's going to make that expression under the radical greater than or equal to 0. Basically, it can't be negative. So it's going to be anything 0 and above, right? So greater than or equal to 0. And then I just want to figure out what x values would make that true. And so if I added 6 to both sides, it would be everything 6 and above, which is what you were thinking of, is what values of x that would make that work. Okay. Everything 6 and above. So just think about what's going on here. 6, if I plug in 6, 6 minus 6 is 0, I can take the square root of 0. If I plug in 7, because it's bigger than 6, 7 minus 6 is 1, I can take in the square root of 1, right? But if I were to plug in like 5, 5 minus 6 is negative 1, and right now, we can't take the square root of that negative. So we're just saying what x values are going to work here. And so when I write my answer, we would say everything from 6 to infinity. And we're going to include 6, because it could be 0. So that's just a scenario where we might use inequalities to answer a question, and especially domain questions. Okay, so those are all what we call simple inequalities because it's one inequality. There's just one inequality throughout the problem. Now we're going to step it up a little bit. And we're going to talk about compound inequalities. Compound means more than one. So if I have a compound inequality, I have more than one inequality. And typically, when we have a compound inequality, it's either going to be an and statement or an or statement. And you won't always have one or the other word in there. If I have an and statement, it may not say and. I'll show you an example of one where it's going to have and, but we're going to assume it to be and. Or we'll always have or written in the actual problem. It'll say this or this. But the words that we're going to think of that associate with those two is and represents both. What numbers are going to be true for this inequality and this inequality? So it has to be true for both inequalities. Or we use the word either. Okay. I'm going to do this or I'm going to do that. Okay, one or the other. So I'm going to do an and first. We'll do some ands and then we'll do some ors. All right, this here is an and statement. If there's no word written in here, then we're going to assume this to be an and statement. Because there's two inequalities, and it's got to be one or the other, and so this would be and. And the way that I would read this, -3 is less than 2x plus 5, and 2x plus 5 is less than or equal to 7. So I could write it out as two separate inequalities, and sometimes it may be written out as two separate inequalities, but really here, we don't need to do that, okay? We're going to leave it just like it is. Because the easiest way I feel to solve this is just like we always do, we're going to get x by itself, right? We have 2x plus 5 as our expression. We want to get x by itself. So our first step is we're going to subtract 5. But here's the difference. When I subtract 5, I'm going to do it to the left, the middle, and the right. I got to do it to all three parts. So -3 minus 5 would be -8. Is less than or equal to 2. And then we still got to get x by itself. So now we're going to divide by 2. And once again, we're going to do it to the left, the middle, and the right. And keep in mind, if I ever multiply or divide by a negative at any point in time, we got to change the sign. We're not dividing by a negative here, so we're in good shape. So -4 is less than x is less than or equal to 1. Okay, so my answer looks a little bit different than the ones we did earlier because we have two inequalities in it. So this would be like our part A. This would be our inequality expression. And then we're going to do the interval notation and we're going to graph it. So I'm going to put -4 and 1 on the number line. You don't necessarily have to count every single number on the number line. I'm just going to put them so kind of show in relationship where they are. Make sure -4 is always further to the left. And we're saying x is between -4 and +1. So that means because there is not an equal to here, it's going to be a parenthesis. 1 is going to be a bracket because it has an equal to sign. And we're shading everything in between. Okay. So what's going to happen a lot of times when I do an and statement, ands are going to meet in the middle. So I'm starting at -4 over here and 1 over here, and these two are kind of coming together. Okay, but it's not going to extend past these two. When I do my interval notation here, I'm saying all x values from -4 to 1, including 1. So if I think about numbers that would work here, it just has to be greater than -4 and less than or equal to 1. So we could do numbers like -3, -2, -1. 0 would be a great one, right? I could come back up here. I could plug 0 back into this. 2 times 0 is 0. 0 plus 5 is 5. Is 5 somewhere between -3 and 7? Which it is, okay? And that's how we could check it. Kind of like yesterday. If you have the ability to check, why not check it, right? I'm not going to see or care if you show me your check, but if you ever worry if my answer looks right or feels right, you can always plug it in on problems like this. And there's a lot of things. And that's the big difference here is that yesterday there was just one answer that worked. Here, there'd be a range of numbers that could work. All right, so that's what we call an and statement. And usually on those you're going to have inequalities, 2 inequalities, and you're going to have symbols on either side. This could be 2 brackets, it could be 2 parentheses, it could be any combination of those symbols. Okay, if I do an or statement, the only way that an or statement will ever be written out is with the actual word or in between. Whereas an and statement doesn't necessarily have the word written in there. Could have, but won't always have. We're going to solve these two separately, and then we're going to look at what our answer looks like. And writing these out is going to look a little bit different. I will tell you this right here. One way that I remember ors to kind of help me remember what's going on here is most of the time, not 100% of the time, but a majority of the time, ors are going to go away from one another. They're going to go in opposite directions. You got one going this way, you got one going this way, and they won't meet in the middle. They could meet in the middle, but majority of the time, they will be going away from one another. Okay, so on this one, we're going to solve both of them. We got 2 of them that we have to solve for. So 2x is less than or equal to -2. Divide by 2. X is less than or equal to -1. Or, and then we add 5 and divide by 2. And so that would be like our part A. 2 separate inequalities with the or statement in between. Okay, interval notation is going to look a little bit different here. I'm going to do my number line first. -1 is going to be a bracket, and it's going to be shaded left. 3 is going to be a parenthesis, and it's going to be shaded to the right. These two never touch one another, right? They're going away from one another. They're going in completely different directions. And remember we said one or the other. So I could have any number that's less than or equal to -1 or any number that's bigger than 3. Any number that's in between these two is not going to work or satisfy this inequality. When I do interval notation here, here's why it looks a little bit different. I'm going to go all the way to the left on my number line. So we're going to start all the way to the left at -infinity. We're going to move all the way up until we get to -1. And we're including that. And then we have a little break in the graph, right? So what we do is we do this little U symbol to we're going to join these two together. That just kind of shows us there's a break in the graph for a little bit. And then we're going to start over again at 3 and we're going to go from 3 to forever. So 3 to infinity. So anytime we have a break in the graph like that, we'll just throw that little U symbol in there. All right, to finish up real quick here, a couple of special situations that could happen or that you might see. I always kind of like to show you these because we won't see these things very often happen, but they could happen. And so you need to be kind of aware of them if they do happen. And really here, what we need to understand is what's going on and what the word and means. If I said what numbers are less than 2 and at the same time bigger than 5, what numbers are less than 2 and also bigger than 5? Nothing, right? There is nothing that works there. So that would be no solution. There's nothing that's less than 2 and also bigger than 5. If I were to make a number line here, it would just be an empty number line. There's nothing on that number line that works. There's no shading, there's nothing. It's just empty. Okay, so we call that no solution, or sometimes you'll hear it referred to as like an empty set because there's nothing in that set that would make it work. Okay, so that's one kind of special situation. Another one, I told you that or should go opposite, okay? And these two do go opposite, but what happens here is if we look at our number line, 2 is starting here, 5 is starting here. 2 is going to have a parenthesis shaded to the right. 5 is going to have a parenthesis shaded to the left. Okay, so they cross over one another. They are going different directions, but they're actually crossing over one another as well. There's no empty gap in the middle like there was on that one we did a few seconds ago. So what set of numbers here would work? All reals, everything, okay? Everything on this would work. And if I was going to do my interval notation here, I would just do what we've seen before with like domain negative infinity to positive infinity. Hey, you also could see, and I could give you one like this. I won't see this one very often either, but if I said x is greater than 2 and x is greater than 5, if they're both going the same direction, that kind of changes things a little bit. This one won't happen very often, but here's 2, here's 5. What numbers are bigger than 2 and also bigger than 5? Yeah, and anything to the right of 5, okay? A number like 3 would not work. It's bigger than 2, but it's not bigger than 5, okay? So my answer here would be anything greater than 5. And we wouldn't have to graph the numbers between 2 and 5. Okay. If I changed this to or, then it would be everything from 2 and above, because then 3, 4, and 5 would work, right? So just a couple of situations that could be a little bit different. All right, last homework assignment for chapter 1. So, sometimes I know I write down like page numbers. You might make sure all the numbers are on that. I may not always write both page numbers. It looks like 5 through 40 is all on one page here, but I try to write all the page numbers down, but sometimes maybe I didn't get it written down. Here it's just on one page today.